Space is our last frontier. The Cheops Space Telescope travels throughout this boundless space. Its ongoing mission is to search for and study exoplanets. Or, to put it differently, explore strange new worlds. But the search for life and new civilizations has thus far only been done in Star Trek. The European Space Agency launched the Cheops mission back in 2019 to study previously discovered exoplanets from Earth. The prefix exo means they're not in our solar system. This makes sense, given we all know our 8 planets well enough. Although this is not an entirely correct statement. With the help of powerful ground and space telescopes, astronomers had, by the end of January 2022, discovered 4,949 exoplanets. Thousands more space bodies, decent candidates for this title, are under their close observation. Those space objects that have solidified their right to be called planets belong to various solar systems, of which there are more than 3,500. They are scattered throughout the visible universe, the scale of which is impossible to imagine. But why all this global space fancy? Well, to understand just how unique and mysterious the WASP-103b is. The technical name of this exoplanet spoils the whole aura of magnificence and mystery, and how it is referred to in its, well, homely way definitely destroys that aura completely. The Potato Planet. It just doesn't sound right. The WASP-103b should have been given a much more interesting name. Among the almost 5,000 discovered exoplanets, there is not a single one like this one. It is absolutely unique due to its shape. And yes, it does really look like a potato. Another commonly used comparison is the American football ball, but the essence is still the same. It's no secret that space bodies have different shapes, sizes, and other parameters. There are asteroids and comets that look like unhewn cobblestones, slightly crooked satellites, or even the planets themselves, too. You probably know that Earth is not really a sphere, but technically a geoid. To be honest, it looks more like a poorly made snowball overall. Nevertheless, it's as close as it could be to a spherical shape. And with the atmosphere the way it is in general, it's the ideal sphere for us. Although most of the other planets, as well as various large cosmic bodies, tend to take on just such a form. Gravitation contributes to the general cosmic rounding out. Under its influence, all points on the planet's surface eventually end up at approximately the same distance from its center. Making allowance for the scale of these creations, of course, although oftentimes a discrepancy of only a couple of kilometers is not all that noticeable. But back in 2014, astronomers discovered an exception to the rule. The gas giant WASP-103b. This planet is located in the constellation Hercules at a distance of about 1,800 light-years or 552 parsecs from Earth. For comparison, the Ursa Major Dipper stars are an average of 120 light-years away, and the Southern Cross stars are about 490 light-years away. WASP-103b is classified as a gas giant, so it is compared to Jupiter, which is also a gas giant. But the exoplanet is twice the size of its brother in our solar system and about 1.5 times its mass. An important feature of WASP-103b is its extreme proximity to the parent star. First, let's list off a few numbers for later comparison, so as to truly capture the surprise. The planet Mercury, which is closest to our star, is located over 36 million miles, 58 million kilometers, from the Sun. And the Earth is 93 million miles, 150 million kilometers, away from it. From our planet to the Moon, just under 239,000 miles, 384,400 kilometers. On a cosmic scale, this seems rather modest, yeah? Now think about this. The distance between WASP-103b and its parent star is just under 20,000 miles, about 32,000 kilometers. This is so small that even Neptune would not fit in between them. And, by the way, the length of our planet's equator is about 25,000 miles, 40,000 kilometers, give or take. The original parent star of the unique exoplanet was designated as WASP-103. It's more massive than our Sun by a factor of about 1.7 in size, and hotter by 572 degrees Fahrenheit, 300 degrees Celsius. No wonder the planet got all warped, being so close to such hell. As a matter of fact, this is the exact reason for WASP-103b's unusual shape. The planet orbits its star in less than one Earth day. What's happening on its surface at this time? The same thing that happens on Earth due to the rotation of the Moon around it. It ebbs and flows. It is the satellite that causes the daily recurring movement of the oceans on our planet. The force of the Moon's gravity is sufficient to attract water on a noticeable degree, but it is still too weak to noticeably affect the rocky parts of our planet. WASP 103b orbits a giant Hell star. Its gravity is so strong that the tidal force stretches across the entire planet. Back in 2014, scientists assumed that proximity to its star deforms WASP 103b. But it wasn't until the Cheops Space Telescope came into play that the extent of these changes became known. The telescope observed WASP 103b's transit. This is the moment when the planet passes in front of its star. It looks like a tiny black speck against a glowing background. But this is enough for scientists to determine the size of the cosmic body. Due to the fact that Cheops tracked several transits made by WASP 103b, it was possible to detect its deformation. Moreover, astronomers were able to accurately measure it, with such calculations being carried out for the first time. But their main value actually lies elsewhere. Knowing all the external parameters, scientists can determine the composition of this cosmic body. Different materials resist tidal forces differently. Therefore, the shape of the exoplanet tells us how much rocky formations, gas, or water are in it. As for the latter, everything's pretty obvious here. Although WASP 103b is compared to Jupiter in some regards, they have a very noticeable difference. The average temperature on the largest planet in our solar system is about -260 to 300 degrees Fahrenheit, about -130 to 145 degrees Celsius. The potato exoplanet, as you may recall, is evenly fried all over within the immediate vicinity of its parent star. Also on the surface of WASP 103b, there is a large difference between the temperatures on the night and day side of things. With the former, it fluctuates around 2,900 degrees Fahrenheit, 1,600 degrees Celsius, and with the latter about 4,900 degrees Fahrenheit, 2,700 degrees Celsius. At such temperatures, the molecules of hydrogen and oxygen would simply break off, so there's definitely no water vapor there. It's presumed that WASP 103b consists of stones, gas, and liquids. Further study of its deformation will make it possible to understand which parts of it consist of what exactly. Again, all due to the different responses of materials to tidal loads. Scientists have already noticed that the potato planet is very swollen. Given that its mass is 1.5 times that of Jupiter, the planet's size was expected to be proportional, but it actually turned out even bigger. This strange puffiness is the first reason why it's important for astronomers to know what the planet is made of. They've collected data on thousands of other exoplanets, analyzed and organized them, but WASP 103b is something else entirely. So this gas giant definitely has a secret, and it's not alone. The impact of colossal tidal forces is not limited to the fact that they've turned the planet into a rugby ball. These forces also affect its orbital decay. From the name alone, it's clear that this means a shift of the trajectory along which WASP 103b moves around its star. The exoplanet will approach the more massive body until it eventually collides with it. Then the parent star will swallow it up. Such are the physical laws of the universe. But WASP 103b apparently didn't get the memo, because this planet is behaving in a rather anomalous manner. Instead of approaching its star like all normal planets, it moves away from it. In any case, this is evidenced by the data astronomers have obtained thus far. More data is still needed to explain WASP 103b's strange behavior. Meanwhile, scientists have been considering several possible explanations to this mystery. The first is the possible presence of a companion star for WASP 103b. But if so, then other physical laws would come into play, and everything would be recalculated in a different manner. There is also the possibility that would completely eliminate all the mystery behind the behavior of this exoplanet. Scientists have not discarded the idea that their data is simply incorrect. This, you know, is not something measured with a simple ruler on paper. It's outer space after all. Until an observational error is proven, WASP 103b remains unique. But this does not mean that something similar does not exist in the universe. Approximately 1,200 light-years away in the constellation Auriga is WASP 12b. This is also a gas giant, about the same size as the potato planet. It's egg-shaped and orbits its parent star in a little more than one Earth day. It's all very reminiscent of WASP 103b, only in this case the laws of physics work as expected. The parent star is already tearing this planet apart. Very soon, at least by cosmic standards, it will cease to exist. I guess we'll wrap things up here concerning the potato planet. We'll let scientists continue to puzzle over this riddle while we check out Haumea. Now that's a proper name for a rare planet. It looks like a flattened rugby ball, but the most interesting thing about Haumea is that it's located within our solar system. Were you aware of its existence? Of course, it is worth clarifying that this is a dwarf planet. There are 4 more of these in our system: Ceres, Eris, Makemake, and Pluto, which you probably knew already. Haumea was discovered by 2 groups of astronomers simultaneously. The Americans noticed it back in 2004, and instead of immediately announcing the discovery, they decided to study everything in detail. And then, while they were preparing documents, this new object was discovered by a Spanish group of astronomers in 2005, which was immediately announced to the public. The planet was named after the Hawaiian fertility goddess Haumea. It makes sense that the 2 satellites discovered later received the names of her daughters, Heaka and Namaka. The unique nature of this dwarf planet lies in the speed of its rotation around its axis. It completes a full revolution in just 4 hours. This makes Haumea the fastest rotating object in our solar system. This is also the reason for its oblong shape. The planet is stretched out over 1,400 miles, 2,300 kilometers, along its longest axis, but only 619 miles, 996 kilometers, along its shortest one. Some scientists are trying to remove Haumea's status as a dwarf planet since it's too elongated. Pluto has already experienced a similar overturn regarding its planetary status. In actuality, Haumea is just behind it. Both cosmic bodies are called trans-Neptunian objects, since they are located beyond Neptune, the 8th planet of our system. Due to such a remote location, Haumea needs as many as 285 Earth years to complete a full revolution around the Sun. It is currently believed that it consists almost entirely of rocks and is covered with a thin layer of ice. Back in 2017, astronomers discovered rings near Haumea, these being much more modest than those of Saturn, of course. And it also has a red spot on its surface, almost like the one on Jupiter. Apart from the shape, Haumea has little in common with the WASP 103b, but even such a feature as that is enough for these planets to attract astronomers' attention. Strange celestial bodies shaped like a potato, an egg, or a rugby ball are certainly more interesting to study than the other ubiquitous spheres. In all seriousness, the answer to such cosmic phenomena as WASP 103b allows us to develop science, and sometimes even change the course of history. Did you know these elongated planets existed? One of which is actually in our own solar system, no less?